Hey everyone, welcome back to my channel. Today I'm super excited to show you my latest project, a fully interactive portfolio website built with React, TailwindCss, 3JS and Framer Motion. This project combines some of my favorite tools to create a visually stunning and dynamic user experience. Let's dive in and take a look at the key features. First, the background features a custom GLSL shader I created using 3JS. I also added falling sakura petals using 3JS particles, which adds a touch of elegance and motion to the design. Here we have a button that allows users to turn the music on. This means our website includes background music to enhance the experience. The UI is clean and responsive, built with React and styled using TailwindCss. I used Framer Motion to handle the smooth animations and transitions you see here. And when I hover over the button, petals explode and the neon flicker effect adds a nice touch. In the scale section, each scale is displayed with a circular progress bar that smoothly fills up as you scroll. We have a slider of project cards that smoothly appear and slide into place as you scroll. The transition between the cards is fluid thanks to Framer Motion. We also have a contact form designed with simplicity in mind, and of course we have the footer. And finally, I've added a back to top button, making it easy for users to quickly navigate back to the top of the page. The portfolio is fully responsive. It looks great and functions perfectly on any device, whether it's a phone, tablet or desktop. Since the versions of the tools I use might change in the future, I leave a link to the GitHub repository in the description. You can download the project and run npm install to install the dependencies. In the package.json file, you can find all the packages I used for this project. For example, Iconify React is used for icons. To use an icon, all you need to do is import it into your component and add it like this. You can go to the Iconify website, search for the icon you want and use its name directly. React 3 Fiber is for handling 3D graphics with React, and Framer Motion is used for animations. The project is built with React 18. I also included short UUID for generating short unique IDs. Finally, 3 is the core library for 3D rendering. You can find the custom shader file in the source folder. Copy it to the components folder. Great, now that you've copied custom shader to your component folder, let's take a closer look at that file and break down how it works. First, we import 3JS for 3D rendering, React 3 Fibers extend to add custom objects, and short UUID to generate unique keys for our shader material. Next, we define our custom shader class. This class extends 3.shader material, which is the base class for materials that use custom shaders. Let's break this down. The uniforms object holds variables that can be pasted from the JavaScript code to the shader. Here we have time, which will animate our effect. in two colors, color start and color end. The vertex shader is responsible for positioning vertices in 3D space. In this case, it's pretty simple, we're just passing the UV coordinates to the fragment shader. The fragment shader is where the magic happens. It calculates the color of each pixel on the screen. The fragment shader uses Perlin noise to create smooth, swollen effects by blending colors based on direction and distance. A radial gradient makes the colors fade out at the edges, and smooth step makes the transitions look smooth. Finally, we register the shader with React 3 fiber using extend in the unique key, making it available as a JSX element for seamless use in our components. Now let's move on to 3 background component. This component will handle our 3DS scene and animations, including the shader background in Sakura puddles. First, we import React hooks, use effect and use ref to manage our 3DS scene inside the component. We also import 3DS and our custom shader. Here, mount ref is a reference to the div where we'll attach our 3DS canvas. Inside use effect, we create a new 3DS scene and a perspective camera with 75-degree field of view. The aspect ratio is set based on the window size, and we place the camera a bit further away at z equals 10. We create a WebGL renderer with anti-aliasing enabled for smooth rendering and set it to be transparent. Then we attach it to the mount ref div. Next, we create a large plane geometry and apply our custom shader material to it. This will serve as the animated background effect. To add funny Sakura paddles, we first load the paddle texture using 3JS Texture Loader. Here we create 100 paddles. Each paddle is created using a flat plane geometry with a size of 0.4. Then a texture is applied with mesh basic material. The material is transparent and visible from both sides. Each paddle has a random position, fall speed, sway speed, and rotation speed to make the animation feel natural. Now for the animation, we use a clock to track time and update the panel's positions, creating a realistic falling in twin effect. If a panel falls out of the view, we reset its position at the top. To keep our scene responsive, we listen for window resize events and update the camera's aspect ratio and render size. Finally, we clean up by removing the event listener in the 3GS canvas with the component on mounts. I will use the vidconfig file to set up path aliases, making imports cleaner and more efficient. For example, instead of writing long relative paths like this, I can just write this. To do this, I define the alias add components in the vidconfig file, pointing directly to the source components folder. Create the NavBar folder and then NavBar items component inside it. First, we import React and Motion from Framer Motion to add animations to the list items in the NavBar. Then we define an array called items, where each object in the array has a name for the link text and an ID to identify the section of the page to scroll to. This array will later be used to create the NavBar items dynamically. Next, we define a function called handleScroll. This function will help us scroll smoothly to the section of the page when a NavBar item is clicked. It uses document.getElement by ID to find the corresponding section, and without that scroll to scroll there smoothly, with a slight offset to ensure the navbar doesn't overlap the section. We then set up animations for the entire list of navbar items with navlist. This object has two states, visible and hidden. When the navbar is visible, we apply an opacity transition with a staggered effect. The children of the list, the individual items, appear one by one with a slight delay. When hidden, the items fade out and stagger in the reverse direction. Similarly, we define the animations for each navbar item with the navItem object. It defines a smooth vertical movement and opacity change as the items fade in and out. Now, in the return statement, we use motion.ul to animate the entire list of items. We pass navlist as the variance prop to control the animations of the whole list. We also map through the items array and render each item as motion.la, which allows each list item to have its own animation defined by the navItem variant. Finally, we use onClick event on each item to trigger the handleScroll function, which scrolls the page to the correct section when a navbar item is clicked. We import the necessary libraries React useState, useEffect, and useRef from React, navbar items to display the actual navbar links, motion and animate presence from Framer Motion for animations, and icon from Iconify React to use icons in the buttons. We then create a functional component called navbar. Inside the component, we set up two state variables, is toggled and is plain. The toggled state will control whether the menu is open or closed, and is plain will determine if the background music is playing or paused. We use useRef to process the audio elements across renders. This allows us to play or pause the music when the user interacts with the play/pause button. Next, we use the useEffect hook to handle the audio playback. Whenever is playing changes, we either play or pause the audio accordingly. We define an animation object navContainer to control the motion of the navbar when it's shown or hidden. The visible state of the navbar has an opacity transition while the hidden state has a smooth exit transition. Inside the return statement, we first render two buttons, one for opening and closing the menu and one for playing or pausing the music. For the menu button, we toggle between the menu and close icons depending on the state of is toggled. For the music button, we toggle between the play and pause icons based on the state of is playing. Finally, we use the Animate Presence component from Framer Motion to manage the animations when the navbar appears and disappears. If is toggled is true, the navbar will be displayed as a motion.div with the animation controlled by the nav container object. Now let's talk about the hero image component. This component is responsible for displaying and animating the profile image in hero section. First, I import React and Framer Motion since we're going to add an animation effect. Inside the hero image function, I create a div with some Tailwind classes. This div acts as a wrapper and positions the image correctly. I set it to be absolutely positioned, centered, and with a circular border to match the design. Now, inside this wrapper, I use motion.image, which comes from Framer Motion. This is a special image tag that allows us to animate it smoothly. For the animation, I define an initial state where the image starts slightly lower with zero opacity. Then, in the animate state, it moves up and fades in. I also add a transition with a delay of 0.5 seconds to make it feel smooth and natural. Now let's move on to the hero text component. This is the text section of the hero section, and it includes the main heading along with social media icons. Inside the component, I start with an h1 tag, which contains the name. I animate this heading by making it fade in and slide up when the page loads. For the last name, I apply a cool text effect using WebKit text stroke, which gives it an outlined look while keeping the inside transparent. This part also has a slight delay in the animation to create a nice staggered effect. Next, I add social media icons. These images are wrapped inside a motion.div and they all appear with the same fading and slide up effect, making the entrance feel smooth and polished. Hero description component is responsible for displaying experience in the brief description in the hero section. I've split this into two versions, Hero Description MD, which is designed for mobile and medium screens, and Hero Description Desktop, which appears on larger screens. Both components share the same structure. At the top I have a simple experience indicator, sight to be clear and readable. Then I display a description, but instead of showing it all at once, I animate each word individually using frame of motion, creating a nice progressive ripple effect. Alright, before I create the actual button component, I need to style it first. So I start by adding a new CSS file. Now I'm defining some CSS variables for the neon effect. These will control the different glow colors. Next, I'll apply these colors to the button's border in text shadow to give it the cyberpunk neon look. The cool part is this flicker animation. I want the button to glow but also have moments where it looks like a real neon sign, blinking on and off. Now after creating our button CSS class, let's take the next step and organize our project better. I will create a reusable folder where I will store all the components that I might use multiple times across the project. Inside this folder, I will create a button file. This will be our reusable button component, styled with the neon effect we defined earlier. We use motion dot button from framer motion to add a hover effect. The button will scale up slightly when hovered, creating a smooth animation using spring physics for a bouncy feel. Handle hover function runs when you hover over the button. It generates 20 paddles, each with random positions, rotation, and scale to make the effect look more natural. When hovering over the button, we map over the paddles array and render each paddle as an image tag. The paddles will float away from the initial hover position with smooth animations, using framer motion's initial, animate, and exit props to manage the transition effects. transition with duration 5 in is out is set to make the paddle slowly fade away. Alright, it's time to dive into the services component. This section will showcase the different services offered, each with a unique animated card effect. First, I'll start by importing the necessary dependencies. Next, I'll define the animation settings for the service cards. I'll create an object called card variants, which will handle both the initial state and hover effect. When a user hovers over a card, it will slightly scale up, tilt in 3D, and add a soft pink shadow for a floating effect. Once the hover ends, it smoothly returns to its original state. Now I'll set up the section layout. It will take up the full height of the screen, be centered, and have a blurred glass effect for a slick design. Next, I'll create a responsive grid to display the service cards. On smaller screens, it will show one column, and on larger screens, it will expand into 3 columns. I now define an array of services, each containing a title, description, and an icon, and I'll map through them to generate the cards dynamically. Now comes the animation part. Each card will be wrapped in a motion.dave, which will apply the hover effect from the card variants object. Now I'm going to create a title component that will be reusable throughout the project. This component will be responsible for displaying section headings with a stylish stroke effect and a smooth animation when it appears in the viewport. The title component will take a label prop, which will allow me to reuse this component with different section titles. Inside the component, I will create a ref using useRef to keep track of when the element enters the viewport. Then I'll use usingView, passing in the reference and setting it to trigger only once when the element is 100 pixels inside the viewport. Now I'll create the motion.h1 element to animate the title smoothly when it becomes visible. To create a unique visual effect, I'll apply WebKit text fill color transparent and WebKit text stroke 3 pixel wide. This gives the text a bold, outlined look instead of a solid feel. Now let's animate it. I'll set the initial state with an opacity of 0 and a slight downward position. When it enters the viewport, it will fade in and move up smoothly. Now let's dive into the About section. This section will showcase experience and education, along with a downloadable resume button. Alright, now I'm going to create a separate file for animations because I'll be reusing them across multiple components. Instead of repeating code, I'll define them once and just import them wherever needed. I'll start with the feeding up animation. This animation makes elements feed in and move up when they appear. Now I want a hover effect for my cards, so I'll create card hover. This makes the card lift slightly, grow a bit, and add a soft glow when hovered. Next, I need an animation for staggered elements, so they appear one after another instead of all at once. This tells frame of motion to animate child elements with a delay between each one. It's great for lists or grids where I want things to appear smoothly. Now that I have these animations ready, I'll use them in my experience component to bring everything to life. Now let's break down the animation logic. The initial equals hidden means the card starts hidden, and while in view equals visible makes it feed in when it comes into view. I also added while hover equals hover to give the card a nice hover effect like lifting and adding a box shadow. I use viewport once true amount 0.5 to trigger the animation once the card is 50% visible. Finally, I combine the feeding up and card hover variants to apply both the entry animation and hover effect. Alright, let's dive into the skills component. This component will display a list of skills with their proficiency percentages. I'll create a grid layout to display my skills in columns. Each skill will be animated using motion.div. For animations, I set initial equals opacity 0 y50, so each skill starts hidden. Then, with while in view opacity 1 and y0, it feeds in as we scroll. The transition adds a slight delay for a staggered effect. Now for the fun part, the circular progress bar. I'll use an SVG with a background circle and an animated progress circle. The progress circle uses stroke-offset to animate from empty to a value based on the skill percentage. This creates a nice fill-in effect. To make it more dynamic, I'm adding a gradient to the stroke for a smoother color transition. Right in the center, I'll display the percentage using motion.span, making it count up from 0 to the actual percentage. Finally, I'll add the skill name below for clear labeling. Now let's create a project card component to display each project. This component will receive a project prop. Next, I'll define some hover animations using frame of motion. The card will move up slightly, scale up, and have a soft shadow on hover. Now let's return a motion.div that wraps the entire card. I'll apply the hover animation by setting while hover and passing variance equals card variance. To give the card a stylish look, I'll add a blurred glass effect and a border with soft white transparency. For a nice visual effect, I'll add a subtle gradient that appears on hover. Next, I'll create an image container and display the project image inside. Now I'll add the project title and description. Finally, I'll add a button to view the project, making the card interactive. Now let's create the project section to showcase all my project in a horizontal carousel. Since this will be a horizontal scrolling carousel, I'll create a user hook to reference the container. Now I'll add frame and motion variants for animation. When the carousel appears, each project will feed in one by one with a slight delay. Next, I'll create the carousel container using emotion.div. It will have overflow X auto for horizontal scrolling and snap X snap mandatory for smooth snapping. Each card will slide in from the left when it becomes visible. Finally, I'll pass the project data for the project cards component. Now I style the scroll bar to match my theme. First, I set the height of the scroll bar to 8 pixels for a sleek look. Next, I style the scroll bar theme, making it my primary color with rounded corners. Finally, I'll give the track a subtle background with some transparency to blend nicely with the design. Now I'm adding a contact form to my project. First, I define the form state using useState to manage user input. Next, I create a function to handle input changes and update the state dynamically. Then I define a submit handler, but for now it just prevents the default from submission. I also store form field details in an array for a clean and reusable structure. Now I wrap the form in motion elements to animate it smoothly. Each field is mapped dynamically in the use of floating label effect for a modern look. Now let's talk about the core part, rendering input fields dynamically. Instead of manually writing separate input in text area elements, I use a conditional inside the map function. If the field type is text area, it renders a text area component. Otherwise, it renders an input field for text or email types. This approach keeps the form flexible. If I ever add a new field type, I can just modify the fields array instead of duplicating code. Now, both inputs in text area share a similar class for styling, ensuring they match visually. Finally, the floating label technique uses peer and peer plus holder shown classes to animate the label when the field is focused. Now let's move on to the two-tap button component. This component is a floating button that appears when the user scrolls down and disappears when they scroll up. I create a state variable is visible to control when the button should appear. Next, I use useEffect to listen for the scroll event. Whenever the user scrolls down more than 200 pixels, I update is visible to true. Now I define a function scroll to tab, which smoothly scrolls the page back to the top when the button is clicked. Finally, I return the button. I use frame of motion to animate it. The button will fade in and out depending on is visible. And that's it. Now, whenever the user scrolls down, the button appears. Clicking it will bring them back to the top smoothly. Let's move on to loading spinner component. I create an object called variants, which holds three animation states: hidden, visible, and hover. These are for controlling how the loading spinner and its elements behave as they appear, animate, and interact with user actions. I use a loop to render 5 animated circles. Each circle uses the variance object to animate, starting with the hidden state, then transitioning to the visible state with a slight delay. They are all positioned in the center of the screen, and I use a gradient color for each one. I also add a while hover animation for interactive hovering. Next, I add 20 small white circles that will animate randomly across the screen. These circles feed in and out while also moving vertically and horizontally. The movement and feeding are randomized so that they appear as if they are floating around. The animation is set to repeat infinitely with a smooth transition. To finish up, I display the loading text near the bottom of the screen. It starts off hidden and smoothly fades in as the page loads. This adds a nice touch to indicate to the user that something is being loaded. We're setting up a state variable is loading using useState and initializing it as true, because the component will start in a loading state. Next, we use useEffect to run a function with the component mounts. This function we set is loading to false after 3 seconds, simulating the end of a loading process. Finally, we conditionally render the loading spinner component while its loading is true, and once the state changes, we render the main content. Thank you so much for watching. If you found this helpful, don't forget to hit the subscribe button for more content like this. Also, make sure to turn on the notification bell so you never miss an update. See you in the next video.